Technology and AI is unlocking new secrets about our microbiome. We are each affected differently by different gut microbes and the way they behave. Despite all of the recent advancements in the fields, there are still many unknowns. That's why Dr. Amine Zorgani and his team at SwipeBiome are using technology to identify and control what's going on at an individual level. I'm Dr. Karan, and this is Dr. Karan Explores, where we cut through the BS of modern health advice and tackle the biggest issues in health, science, and medicine. If you've been enjoying the podcast so far, I'd love it if you'd consider subscribing to the show so we can reach even more people. So let's get into it, and let me introduce you to microbiome expert, Dr. Amine Zorgani. Dr. Amine Zorgani, welcome to the show. It's not very often that you can genuinely call someone a microbiome expert, and I'm thankful I can call you a friend as well. I just want to dive straight into this. There is so much buzz around microbiome, around gut health. Will we soon be able to create new foods and disease treatments that actually boost the guts and overall health?
Dr. Karan, thank you so much for having me on the show. Very pleased, and I return that to you, my friend. So very pleased to be here. You asked one question which has a lot of questions into it. Can we make foods that actually modulate the gut, or can we make therapeutics that do? It depends on which disease areas we're talking about. Number one, when we speak about the microbiome, we tend to focus more on the gut microbiome because one of the most research areas, and also the one that connects almost every kind of disease we know so far. There are some who claim that 95% of diseases mostly start from the gut microbiome, one way or another, connected directly or not. But we should not forget that there are other microbiomes, that the skin microbiome, the oral microbiome, the vaginal microbiome, or even the infant microbiome, which is a different category as well that we may dive into it. If we focus on the gut microbiome itself, we do and we have learned a lot. We've learned what we call them the keystone species, or the bacteria. Mostly, again, here another nuance. When we speak about the microbiome, we tend to mostly focus on the bacteria, while a microbiome definition is not just bacteria. It's bacteria, fungi, yeast, and viruses, and so on. So, but let's just focus on the bacteria. We do know what are the commensals and beneficial bacteria, at least to some extent. We can count them on probably on two people's hands. We call them the keystone species, that if they increase or decrease, we will tend to see someone with the disease XYZ. We do know very well what are the pathogens that are influencing the balance of that microbiota. Now, the question, can that be actionable? Can we actually use it to modulate the microbiome? It depends, again, on which types of diseases. There are some where we can where we're talking about inflammatory bowel disease, some related type 2 diabetes in some very limited cases. But those who claim to be able to modulate the microbiome with 1-2 bacteria in cancer, sorry, I mean that's not possible today, because again, it's an ecosystem that is highly variable, highly personalized. It's very difficult for just one bacteria to be able to kind of modulate it, unless you take a holistic approach that does not only involve adding some random bacteria as probiotics, which I'm not saying that it don't work. I'm just saying it needs to be personalized. It needs to be profoundly thought about. But there are other approaches where you can actually maintain that microbiome balance with food, or food-derived component, which can be in the form of prebiotic, as an example.
Now, I mean, you mentioned there that this figure that I hear a lot, 95% of diseases start in the gut. I don't know who brought out the statistic, and I am leaning more and more towards the fact that this has some significant basis. The specific number of 95%, I don't know about, but certainly we know now that the gut has a role in more than just beyond forming feces and bowel motion. It has all of these other downstream consequences to different body systems and different body organs, to the skin, to the liver, to the vagina, to the brain. Given that we know that there is this hub and spoke model with the gut and other disease systems, disease organs, what types of diseases and issues could we address in a way that we've never been able to before by improving gut medicines and gut therapeutics?
So, Very important thing, I think, a distinction. Let me just maybe quote this paper or review that was published last week in Cell, on which I put a very long response to that review. The review claimed, and they did a nice work, and then they claimed that there was limited or no connection between the gut microbiome and autism, right? And a lot of parents are listening to us and they say, "Listen, I have an autistic child, and what so?" And you were giving us hope, saying that the microbiome can improve autism, but now you're saying there is no connection. I don't think we should say there is no connection bluntly and then we stop there. What we can see, at least, that when we look into autism, I'm not a doctor. Huh? I'm a doctor in biology, not an MD as yourself. But when I look at it from a microbial perspective and from, let's say, symptoms that are related to the gut microbiome, autistic individuals, children mostly, they have several gut issues: constipation, diarrhea, bloating, cramping, and so on. And these are symptoms that can be modulated by the microbiome, right? So the modulating the microbiome or improving the microbiome, in this case, for instance, with dietary fibers or prebiotics, or in some cases, even a symbiotic combination, can improve the symptoms of the disease, maybe improving potentially the actual coping with the disease itself, right? So when you have a child that is autistic and that is not sleeping because they have bloating or they have diarrhea or constipation, reducing or improving those symptoms will enable them to feel better about the situation and eventually improve their behavior. And that's what I believe was misleading in this kind of reviews, that we tend to think that fixing the microbiome can potentially improve all the diseases, which is not correct, because again, some diseases are more molecular. You have to actually get molecular intervention, which is in the form of a therapeutic. But it also means that interventions that can support the therapeutic are needed, and they go through the microbiome. That's my vision today. After what I have seen so far.
You know, autism has unfortunately become one of the biggest scapegoats of misinformation in medicine. It's erroneous links to vaccines and various other conditions. And, even more recently in the US, Tylenol, paracetamol, and autism linked as well.
Yes.
I think it's unfortunate because, autism and other neurodivergent conditions have so much misunderstanding, misinformation, and stereotyping where it becomes hard to pick out the fact from fiction. And specifically, when you talk about autism and the gut microbiome, I think, as you suggested, it would be very short sighted not to think or assume that the gut microbiome has some role to play in influencing this disease process, this condition, because
Yeah.
I think our understanding of the gut microbiome, we're still learning more and more each day, but we're still in this phase where, is it a chicken or egg scenario? Which comes first, right? Is the dysbiotic gut environment driving some phenotypic traits of autism, or is the autism phenotype driving changes to the gut microbiome? It's difficult to maybe sometimes tease apart, but irregardless of that, I think in our current paradigm of treating not just mental health conditions, but also some of these neurodivergent conditions where we have such limited treatment options, it would be a shame not to explore dietary interventions, lifestyle
Absolutely.
interventions, and microbiome driven therapeutics for those things. And that leads me on to, another point I really wanted to ask you, because this is really where your focus is, over the next few years. How can artificial intelligence help to level up our understanding of the gut microbiome and gut health?
It's I think it's the hype of the hyped moment of artificial intelligence and its use, and there are many researchers trying to kind of unlock the potential of artificial intelligence in microbiome research. I think there are different levels. So the first one, before we even start using artificial intelligence, it's cleaning up our garden. And when I speak by that, meaning cleaning up the data mess that we have in the microbiome research. As you know, there are two arms in microbiome research. There are the public research and there is the private research. When we say about private, is usually the data are locked in their proprietary databases and what so no one can touch. They have their own methods and what so. When it goes into the public, they're funded by different governments and different institutions, and almost everyone do as they please in terms of the data structure and so on. We have a very, very, very big problem today in terms of data standardization, right? So some they do microbiome sequencing, what we call the 16S, which is a small sequencing of the DNA. Some they do metagenomic, which actually sequence every piece of DNA. They have very different extraction protocols and what so. So taking this data and throw it into AI, it's unlikely to unlock anything meaningful because the data is so messy. So that okay, what are you going to get from something messy is something messier probably. So AI can potentially help into making or improving the standardization of the data itself, so that at the point that we would say when we have a cohort of patients of specific disease, we could potentially be able to stratify them better, identify better biomarkers, linking the actual bacteria or the taxon to the actual phenotype, what these bacteria are doing from different angles. Because again, if you take someone's microbial diversity and they're living in Japan and another one living in the UK, it's unlikely they would have the same taxonomic profile or the same bacteria distribution or diversity. However, one living in Japan and one living in the UK, they both need vitamin B12 metabolism. So the function is the same, the bacteria is not. So identifying those nuances to be able to link them to a disease pathway that we can modulate it, not just by throwing just one bacteria or one fiber, but more of a holistic approach. How can you actually identify what therapeutics or what biomarkers can improve the microbiome and eventually improve the host, which basically improve the disease state? And if they're diseased, but if they're healthy, how can you keep them, maintain them healthy? Just one last thing. 2 3 days ago, shared on my LinkedIn post, should a healthy person take probiotic? So very legitimate question, right? I mean, if you're healthy, should you take prebiotic if you're healthy, right? And one friends as well commented and say, should a healthy person eat a healthy food? I mean, it was, I think, ironic in the way he said it, but if you are healthy, even if you're healthy, again, it depends on the definition of what healthy means. That's number one. And number two, assuming you're healthy, assuming you're healthy and you don't have any apparent symptoms of any kind of disease, apparent symptoms. So you may not know there are some things that are cooking. There are many diseases that only show up years after you actually started on the inception of that disease. That's one. And number three, who can tell me today they never eat any processed food, or they never eat any, probably, or drink water that may or may not have some antibiotic contamination or metal contamination, or never go outside where the environment is absolutely brilliant, there is no pollution whatsoever? Who lives in such a world? No one. So even if you're healthy and you're living in a brilliant environment, you cannot guarantee that your body is exposed to only healthy things. So those that exposome that you're exposed to on a daily basis with processed food, with antibiotics and what so, is disturbing your microbiome on a daily basis. So unless you maintain it before it's too late, then I mean, I don't know what to tell you. Like, it's not because you're healthy you should not maintain the microbiome. Even if you're healthy, you're exposed to bad things, and that's where the intervention should come.
You've obviously outlined several things there. So people nowadays are exposed to not just environmental pollutants and toxins in our environment from unnecessary use of antibiotics. Pollution levels are rising around the world. Microplastics, we're learning more about the influence they have on different biomes across the body. People are also experimenting, and healthy people, as you pointed out, are taking prebiotics, fiber supplements, probiotic, postbiotics, a whole heap of different biotics and different things which may modulate the microbiome. Now, the gut microbiome is very resilient, but it also has a limit. It's like a spring that can be stretched too far potentially if we overburden it. On a daily basis, how much variability and change is there to the microbiome on a daily basis, and also on a weekly, monthly basis? Like, what is the baseline in terms of its fluctuation capacity, but also how much we can allow it to vary both positively and negatively?
Excellent question. And there are quite a few papers who actually did what we call them the circadian rhythm of the microbiome. Actually, it changes. Mostly, they looked at it at infants and children, and they've seen there is an oscillation, mostly in the, let's say, the abundance or the levels of bifidobacteria that goes up and down depending on whether the infant is sleeping or not, and it gives you the mood of the babies and the fussiness that they have sometimes. It varies. What's very important before we go into the oscillation of the circadian rhythm of the microbiome is we have to understand that when we speak about the microbiome, usually we tend to say one word, microbiome, or gut microbiome in that sense. But there are two microbiomes. That we'll call it the engrafted microbiota. This is the microbiome that you start getting the first shot when you are born, usually vaginally or not. So you get your first microbial colonizers, and then it grows up with you and it stabilizes around the age of 6 to 7 years old. And you get what we call it the engrafted microbiota. This is more the essential piece of your microbiome that if it gets disrupted, it tends to have different types of diseases and whatsoever. On the top of this one, it sits another microbiome. We call it the environmental microbiota. This is the one that changes if you eat a burger or if you drink coffee, and it oscillates. It doesn't mean if the oscillation or the changes of the abundances will affect you physiologically. It may affect some metabolism that you may have and obviously adapt to it. But the one that is most important to health and disease is more the engrafted microbiota, where we see a loss of specific species. For instance, give you an example: people who are on chemotherapy and do not have a specific bacteria called Faecalibacterium prausnitzii or and Akkermansia municipilia, they tend to have less response to chemotherapy. We call them the non-responder group. These two are keystone species, and they are part of what we call the engrafted microbiota. Now, if you have less of E. coli, for instance, you're unlikely to be sick because there is an oscillating environmental microbiota that actually oscillates during the day. What we have seen once a study was published by the Rob Knight lab in the States from UCSD, they actually followed the microbiota of one individual over 1 month, eating their diet as usual and doing their life as usual. We could see that the environmental microbiota does peaks like the same as your cardiogram, while the engrafted microbiota is mostly stable. The abundances is similar. So I would say if you want to improve a microbiome, you rather focus on the engrafted microbiota. That's the piece of microbiome that is very difficult to modulate. Where the environmental microbiota, it just shifts with your food, diary, dairy eating, or fruits, vegetables, your sleep pattern, your exercise, and so on and so forth.
So, given that we're exposed to so much variation and we have this engrafted microbiome, which is different in every single person, all of our lifestyle exposures are also different. Even twins can be grown up and be exposed to different exposomes over their lifetime, which is why it doesn't
Absolutely.
make sense to apply generic guidelines and generic practices to every single microbiome. For example, we often hear people prescribing or suggesting that everyone should be having at least 30 grams of fiber a day. Now, this seems to be bottom of the barrel recommendations, where we know that 30 grams is a good baseline to start with, but then giving someone a generic recommendation by saying, hey, you should just have this amount of fiber, this really undermines the complexity of fiber, but also the role the microbiome plays. Because, as you know, there are different types of fibers which have different roles, different solubilities, fermentations, different health outcomes
Absolutely.
as well. So, why is it problematic that we give these generic recommendations, not just in fiber, but then we also give generic recommendations in you should only take this probiotic or this biotic if you have this? Because we're all so different, it makes sense to have a more personalized custom approach because of the significant variability in the diversity of microbiomes person to person. Even you and I can respond so wildly differently to, one the same fiber type.
Absolutely. I think so. So, I mean, man, you dive into a topic that is very difficult to unpack. Simply, personalization is a big challenge in the microbiome, and what we say, you cannot measure what you cannot see. If we look into doctors, for instance, and again, I have nothing against my GP. I love him so much. He always fixes me when it's possible. A GP, if you go to a GP and you're sick, let's say you have an ear problem, something is buzzing you, right? You go, he look at you and is like, okay, he takes his thing, he looks into your ear, he tries to get the symptoms. Okay, there is no inflammation. It doesn't look like it's an infection either. I might give you some cortisone to reduce it, but he only look at your symptoms or the things that you share with him. Now, let's assume that that ear buzzing is an inflammation that started in your gut because of food poisoning that had thrown in some pathogens, and there is a dysbiosis that went systemic, and you have some inflammation. Now, the doctor does not have another way of doing that unless they actually go and measure that. They do CRP, for instance, and they look into if there is a sign of inflammation. They may do that and they may not find the inflammation because it was not apparent from the blood test. But that inflammation is probably still sit on the microbiome level. So the microbiome piece is an element that today doctors, they don't see it. So they don't measure it. They cannot act upon it, right? Because they just don't see it. Now, the ones who started to see that are the ones who would they leverage what we call it direct to consumer microbiome testing, right? So direct to consumer microbiome testing, you poop, you send your stool, it comes back after 4 weeks, and then it tells you, okay, you have this XY bacteria, you have more Bacteroides, whatever, and then let's just fix it with XYZ things. The problem with that, I just said, it takes 4 weeks to come back, right? If it takes 4 weeks to come back, and you just asked me the question before this one, it oscillates. It changes on a daily basis. Your environmental microbiota, your grafted microbiota. So if I'm giving you a picture of your microbiome, which is 4 weeks ago, how am I going to anyway act upon it? Am I acting on something that is 4 weeks ago or something that I need today? So this is the biggest challenge today, the medicine that a clinician have in terms of microbiome intervention, because it takes so much time for them to get an answer, so they cannot personalize the intervention upon it. If you go to a nutritionist or if you go to a dietitian, which they use microbiome interventions, they cannot act upon something that is outdated because the microbiome had changed since. Now, a solution is, as you mentioned, AI, machine learning, predictive multidimensional patterns, some of the things that we're working on, are the probable solution to enable predicting not a microbiome as a picture, predicting patterns that enables real-time intervention and hence more personalization. You cannot personalize if you don't have the data, and the data is key because they differ from one person to another, as you just said.
I think also if we look at specific pathological populations, for example, people with irritable bowel syndrome, for example, a lot of the advice they are given, they're mired in old school thinking and dogma, where if you've got irritable bowel syndrome or inflammatory bowel disease, you should be on a low fiber diet. Because often people who have irritable bowel syndrome or gut sensitive conditions may react to certain types of high FODMAP foods or highly fermentable fibers. So then and those are the most common types of fibers, even in supplements, things like inulin, for example, in apples, in bananas, in pears.
Yep,
And they react to
absolutely.
those common foods and they immediately jump to the thinking that fiber's not for me. And then they go on a low fiber diet, which in the short term may cool down their symptoms, but long term, there's a chronic insidious issue that's going to be eating away at their microbiome. So an initial symptom that you have if you consume a generic type of fiber, it's not a problem with fiber, but it's a problem with the system inside you. And that leads us to say that, again, to the point, someone with IBS who doesn't respond well to a fiber or some types of foods or fibers doesn't mean fiber's the problem. It's finding the right types of fiber for that person. So maybe there's an exploration and customization needed. Do you need low FODMAP fibers? Do you need different types of fibers which ferment in the distal colon? So again, in those specific populations, there isn't that level of understanding or customization done from healthcare practitioners to actually help them with the root cause of their disease.
Absolutely. And I think comes back to what you've mentioned earlier, right? Like where AI could help or where technology could help is more for patient stratification, right? So again, today we have what we call them the enterotypes, basically putting microbiome of individuals into different enterotypes or different groups of microbes that will enable us to actually modulate. It's not a personalization. What we call it is a semi-personalization, meaning that okay, if we say IBS with diarrhea or IBS with constipation, they're two different, etiologies of disease. Now, okay, if we have someone with diarrhea versus someone with constipation, they should not be getting the same type of intervention, or at least completely different in terms of fiber content or fiber quality, fiber quantity as well. So doing semi personalization through microbiome stratification can enable us, and this only comes by the understanding of the actual patient environment. I don't think anyone could claim I could modulate the microbiome just by looking at the person's microbiome. It's very difficult because it's just a microbial signature. What's very important, and this is where probably the field is lacking, is all the surrounding metadata, is all the information that the patient can deliver. Okay, what is their disease state, how old they are, what's their BMI, what's their food type. I mean, are they vegetarian, are they carnivore, do they actually work out, how long they sleep, how much water they drink. Very important things, like we are in a trial and where these guys, they say, listen, I have bloating. I mean, how much you consume the fiber. If someone never consumed fiber before and they suddenly start pumping to their gut 10 grams of fiber a day for 10 days, and they don't drink water, I mean, I wonder they would not get bloating because your gut was not equipped to such a thing. And you are not giving them, let's say, the solute, which is the water, to enable that fermentation from happening. So, by all means, increasing your fiber intake if you are an IBS or not, or even healthy, and not doing the right things. Let's say I want to increase my fiber intake and I want to improve my microbiome, but at the same time, I am drinking 10 liters of Coca Cola in a week. So, what are you doing? What are you doing? Like, meaning, like the behavior of the individual should match the actual intervention. If it goes in the other direction, it's unlikely to see the benefit, again, because it's not a therapeutic. Fibers are ingredients that are digested by the bacteria to produce beneficial molecules that supports the body functioning, the metabolites like short chain fatty acids or neurotransmitters that go to the brain for mental health and what so. If you don't support that from a behavior perspective, adapting the way you live, I mean, don't ask yourself, why am I not seeing benefits?
Only 5% of us are feeding our gut properly. That means 95% of us are accidentally starving our microbiomes, and we feel it through bloating, sluggish digestion, and other symptoms and health challenges. That's why I created Loam, a 6-in-1 prebiotic fiber blend designed to cultivate a nourished, thriving gut. Each serving delivers 10 grams of plant-based fibers, making it that much easier to feed the gut bacteria that fuel your digestion, immune system, metabolism, mood, and more. And the best part is it's completely invisible. No taste, no texture, no grit. Loam dissolves into anything and literally disappears into your day. If you want your whole health to thrive, start by feeding the ecosystem that runs the show. Head to www.loamscience.com to try Loam, and exclusively for you, just because you're listening to this podcast, get an additional 10% off with the code POD10. Again, that's POD10 to try Loam and get an additional 10% off. Loam, health grows here. We've seen AI being used to model and create new structure types of antibiotics. We're in the midst of an antibiotic resistance crisis, so we need new paradigms and new ways of thinking around producing novel antibiotic types. And AI has been playing a pretty pivotal role in helping us find, new target sites for antibiotics. But also, I've seen in the nutraceutical industry a lot more companies using AI to unlock bioactives from nature. Previously kind of locked away bioactives from plant compounds, which humans don't routinely consume. They've managed to unlock bioactive peptides, unlock maybe some probiotics, prebiotics from all of these different plants. So, how can we use AI to continue to leverage that knowledge and unlock new therapies, which could be used not just in the nutraceutical industry in healthy populations, but actually in disease populations? Maybe a new biotic that can, help in a certain way for a specific outcome.
I think so. Definitely, AI can do something there. Only if it's connected to other technologies like metabolomics, for instance, metaproteomics or genomics that enable us to not only understand how microbes in a network and ecosystem behave. Again, imagine if someone, a healthy individual, today they may have around like 750 different species in their gut, different species, not speaking even about strains, where we're talking about thousands and thousands, not even accounting for the phages that actually eats the bacteria, and understanding the nuances, who is which bacteria is talking to what, with what we call the quorum sensing, what molecules are being produced by bacteria A consumed by bacteria B to produce molecule C that is consumed by the body. These are all very, very complex interactions that no human being can comprehend, and only data, technology, and AI can possibly unlock that. In specific scenarios where, for instance, let's say insulin resistance or metabolism of specific vitamins, we see that there are not just one bacteria or one microbe involved into the process. That could be different ones, one leading to another one. So unlocking those steps, understanding the phenotype, the pathways, it's very difficult from, let's say, just one experiment, but we could simulate different experiments. We call them in silico, do experimental simulation that we could cut down from, instead of testing, let's say, 1,000 or 2,000 molecules, we could reduce the number of molecules that we're actually testing from 2,000 to probably 20, so that we focus on that 20 molecules that potentially improve the absorption of specific vitamins through conversion of certain molecules with the microbiota. This is where I see potentially the AI could potentially be leveraged. Now, unlocking bioactives from plants, it's a different story. That requires the understanding or true understanding of what plants actually would have as molecules. Um, AI could potentially, in the beginning, to mimic between the existing therapeutics that we have that already work as synthetic molecules, and identify homologous molecules that we could find in plants, for instance, not for a therapeutic intervention, but rather from a nutraceutical intervention. Very clear example or easy one is today's hype about GLP-1 molecules for weight loss. We have come to see that there are many publications today showing that the microbiome also would have some molecules that produce naturally in the gut to improve weight loss in a similar way or as GLP-1. Not as efficacious, obviously, because it's just a natural molecule and it exists in a very low quantities. Well, GLP-1 is more of a therapeutic in high dose, and you have to inject yourself on a daily basis. But having a natural molecule unlocked from plants or from a microbiome can only enhance the therapeutic efficacy of an existing therapeutic molecule.
Yeah, I mean, I've seen this trend over the last 2, 3 years of natural Ozempic or natural weight loss molecules where people compare things like green tea, oats, berberine, and a lot of natural bioactive peptides and substances to the same outcome you get with GLP-1 agonists, which is not true, obviously. We have our own human endogenous production of GLP-1 and peptide YY and other satiety hormones, yes. And there may exist other molecules, not least fiber and different types of fiber and
Yep,
polyphenols, which can also increase slightly the endogenous production and synthesis of GLP-1, which could maybe help as an adjunct to therapies and maybe have a role to play in weight loss, but they can never be the same efficacy head to head. How much
absolutely.
of an impact do you really feel these GLP-1, these natural GLP-1 agonists or boosters can have that we can get in supplements, that we can unlock from, natural peptides? can it come not to replace GLP-1 injections, but can it come to a point where it actually has a significant role to play in maybe bridging therapy when someone's weaning off GLP-1, to support symptom management when someone's on GLP-1, or even if someone comes off GLP-1 as a bridge to support their changes in their lifestyle? Like, how potent do you think these natural GLP-1 supplements or bioactive peptides can actually be?
I mean, you just, I mean, you gave some of the answer, right? The potency, it depends also on the concentration, right? So again, the body needs a receptor needs an inducer, and if there is no much of an inducer, the receptor stays empty unless you give it what it actually needs, which is the inducer, the molecule that is actually enabling that response. I do not believe that natural molecules produced by the body can be a replacement of a therapeutic, and I never said that, and I don't think it will happen. And that's the same thing that I said about microbiome modulation as a therapeutic angle. In very specific interventions, yes, like FMT, for instance, and what's so. Where it comes to these GLP-1 molecules that are natural, they can be supporting, of course, but replacing a therapy, it's unlikely because, again, it is molecular intervention. The therapeutic has a specific receptor which induces specific pathway to actually reduce the need of eating or having that moment of society. There are other bacteria, for instance, of probiotics. Some of them are even commercialized and been already on the market as a what we call them probiotic, next generation probiotics
Mhm.
that act specifically on society hormones, right? Specifically, ghrelin, for instance, and this is again, they showed compared to a placebo, there is a reduction in weight loss, or there is a weight loss, but it's nothing close to what you see in Ozempic on Wegovy. Yeah, it's not something similar. So now having Ozempic or Wegovy or GLP-1 molecules as an intervention therapeutic, and then weaning off, as you said, with the microbial intervention or microbiome driven intervention could be a good thing. However, for someone who basically on a period of stress or potential weight gain, having a microbial intervention could probably lower the risk of them getting obese or getting high weight, simply because these interventions are shown to reduce weight or increase weight loss, but with a lower extent as you would see with a therapeutic. So, as a prevention, I would highly encourage natural molecule or microbiome derived molecules as an intervention, or even next generation probiotics that scientifically, with the clinical trials showed, and there are two brands already on the market that showing that as a prevention, yes, but not as a therapeutic intervention. I don't think these guys are anyway selling them as a therapeutic because they just can't. It's impossible.
Yeah, I think the primary difference to appreciate is that pharmaceutical therapies like Mounjaro, tirzepatide, Ozempic, etc., they're all highly potent, targeted at specific receptors, either one, two, or three receptors, and have an
Yep,
extended duration of action, so they last longer. We have natural
totally.
GLP-1, which lasts from a few seconds to a few minutes, which is why we cannot compare eating more fiber and producing more GLP-1 naturally to an injection that you take pharmaceutically. Because even though the mechanisms may have some overlap, which is great, the duration of action is the huge difference. A few minutes to basically a week plus. And even these natural molecules, that's going to be their rate limiting factor, right? The potency limitation will be because of the duration of action. Having said that, as you said, they can be used for preventative therapies to reduce the risk of certain things potentially. Do you think, given that obesity is such a complex disease where genetics play such a huge role, early life exposures, dietary factors, stress, and the microbiome itself plays such a huge role, not merely because the microbiome ferment fiber and then produce beneficial hormones, lipids, peptides, and other satiety hormones, but also have a role to play in insulin sensitivity, actually our
Absolutely.
cravings potentially as well. The balance and makeup of our microbiome could influence if we have a propensity to eat more ultra processed foods. It may drive us to certain actions and habits. So, what can we do in terms of manipulating the microbe and even, like FMT, fecal microbiome transplants and other things like that? Is there a role in which in the future we have specific microbiome therapies like poop transplants and poop pills, which have efficacy similar to that of these GLP-1 injections?
So actually, I was asking myself what you're saying. I do some lecturing in the University of Sussex, and one of the slides that I always put back is the slide where we have this obese person and a lean person, and we take the stool samples from each of these guys and we put them into a lean mice in each. The lean mice that took the stool samples or the fecal transplant from the obese person became obese, while the lean mice that took the lean fecal samples stayed lean. What's very interesting is that when you take the lean mice fecal sample and you give it to the obese mice that actually became obese, the obese mice became again lean. So I don't know how we call this, but it's clear causality to me, right? There is a causal relationship. And this was done in 2003, a long time ago. Some more experiments come after that from the Jeff Gordon lab. And he's called the father of the microbiome from Washington, D.C. University. They've been able also to reverse some obesity traits, also from a weight perspective, using dietary intervention, right? And I've always asked myself, we've actually leveraged FMT, fecal microbiota transplant, in mostly C. diff and other kind of diseases, mostly cancer, like graft versus host. And there are very good trials there. But no one yet decided, or at least I don't know of any prominent companies, mostly, doing any FMT on obesity. Although it's one of the first one that showed to work. It's very interesting because probably obesity is not considered as a disease, is looked as a flaw of a society. If you're obese, you need to maybe stop eating. That's what some people tells you. But obesity is a disease. It's a comorbidity that is composed from different issues, right? But yet, no one had looked into obesity from a fecal microbiota transplantation. I don't have an answer to that. Why? Although causality is one of the first very brilliant experiments that have never been done before. Is this mice experiments taken from humans and showing the logic there. Now, one of the other things that I was also looking at, so there is a fact that someone is obese and then probably they cannot stop eating, they have an addiction on food and what so. And not long ago, I was watching a documentary about processed food and ultra processed food. You would, if you Google it, you might not find a lot of papers speaking about the impact of ultra processed food on the gut microbiome. One of the things that comes to my mind immediately on those research, when they were speaking, they were saying actually people, some literally interviewee on that show, they said they just cannot stop eating processed food. They became addicted to it because in some, if you go to the history and how some of the processed food have been manufactured, some of the processed food is actually manufactured by companies that are tobacco companies, right? So some of the tobacco companies own processed food companies, and basically they use the same approach how to get people addicted on food. And the question, again, I'm not here a conspirationist or a sociologist. I just looked at it from a microbiome perspective, and this is one of the things that I will be hopefully working on the next few weeks as a review on article. Can someone, or is the microbiome involved in food addiction? Because again, if you are eating food, that food is modulating your microbiome in a way that we can be predictable. Now, if the microbiome is fully modulated because of the processed food consumption, can that microbiome be tuned towards addiction on that same food? Right? It's a very philosophical question, but I do believe that addiction on food or addiction on processed food in this sense has a link to a microbiome. Now, interventions, they can need to be radical to change that, as I told you before. If you have a dysbiotic microbiota and you just throw in one bacteria, it's unlikely you can modulate it. And that's why interventions like FMT usually needs an antibiotic treatment before FMT to wipe a dysbiotic microbiota and get the intervention to install. And that's why FMT were successful so far, because again, they just decapitate the existing dysbiotic microbiota.
This point about the ultra processed foods and the microbiome raises a really interesting question, just, a full 360 approach. Because, say for example, I'm at home at my parents' house for a couple of weeks and I'm getting great home cooked, fiber rich Indian food every single day. I have no desire at all to have chocolate crisps or any takeaway ever. The thought of those things actually disgust me, because I'm getting this
Mhm.
from scratch cooked food that's high in fiber every single day. So not only am I satiated, but clearly my microbes are satiated as well. They have no distractions.
Absolutely.
But if I'm traveling and I'm not eating or making my own food from scratch, I'm having takeaway food, I'm going out to eat with business partners or with friends, I'm getting used to this ultra processed food. So are my microbes. And I feel more and more like I want to have more processed food rather than home cooked food. And this is not a problem for me because I have the ability to go on and off. But the concern I have is for the early life microbiome. When we have,
Absolutely.
this fertile seeding ground where we've got these tiny humans who we are creating and building their microbiomes. We are giving them exposures, good and bad, pets, urban environments, pollution, antibiotics, but importantly, ultra processed food. The concern comes when we have, and there's a limit to what we can do about this as individuals, as parents. A lot of infant food supplements, but also infant food products are highly ultra processed. Now, they're convenient, of course, because parents are busy, they're stressed, and they need convenient sources to feed their children. But a lot of them have ultra processed ingredients. I wonder what that does to the resiliency and makeup of their microbiome from an early age, which sets up their health for life, but also could set up their behaviors, addictions, and cravings as well.
Oh man, I have two of my own here. I do struggle because again, kids, for some reason, which is clear, like the ultra processed food is designed in a way that gives you addiction. When you put chips on the table, kids tend to finish the package, right? The pack, because again, that's how the food is designed. They don't like to eat fruits, veggies, right? Unless they're in a shape or form they look into like whatsoever. The first 1,000 days of an infant, they're crucial for their immune system development, which is developed in the same way or in a synergistic way with their microbial development. So if we have a bad microbial seeding, as you said, in the first 1,000 days, and this is not one study, there are different cohorts pointing to the fact that a bad microbial seeding in the first 1,000 days, very longitudinal studies showing it increases the risk of different autoimmune diseases, allergic diseases, asthma, psoriasis, atopic dermatitis, which are very common in infants. Even some studies showing that increases the risk of ADHD, although the link is still not very, it's a little bit loose, but I do see it in the kids today. They have a deficit of attention, right? Again, the link is not causal because that's more of an observational. While the causality between microbial deficiencies and autoimmune diseases, allergy diseases, this is causal because we have shown it. There is an increase of different types of diseases that are linked more also to the hygiene hypothesis, which we could see similarities there. And very one is very clear is when COVID hit, we could start seeing that people start cleaning a lot and what so, but in the same time they start getting sicker, right? Because again, there was less microbial seeding, less and less people take their kids to play in the ground and what so. So I have kids my own, 3 and 6. One of them just turned 6 last weekend, and I do clearly see that when I increase their intake of fiber, when I increase giving them some dose of probiotics. Here, probiotics for the early stage of life is crucial because there are some microbes and their gut microbiota is less diverse, right? So you could do probiotic modulation more efficiently than you do it for an adult, because an adult probiotic stays in the gut for between 48 to 72 hours. We call the engrafting of that probiotic. While for a baby or a kid beyond or below 6 years old, it can stay up to 2 weeks, colonizes their gut. So a probiotic intervention for a child makes even more sense. And there are some species that are very strains that are very well known to colonize their guts, and they are available. I do that with my own kids because they don't like to eat fibers, unfortunately. So I do my tricks and ways to get them to eat fibers, like in soups, although they're cooked. But we need some interventions where it's convenient, but it also brings the value, like highly soluble, tasteless prebiotic drink, for instance, or prebiotic solution, which is, in my opinion, very much needed for almost every parent, which are today struggling. You go into the market, and I tend to read the packages for these. They call them prebiotic gummies.
Mm.
Trust me, there is only the gummy from the package.
Yeah.
There is almost no prebiotic in it. I mean, even if you take the whole package, you're unlikely to give the right amount of to your child. So I do believe that the market is lacking interventions that are designed for 6 7 years old and below, which gives them the right amount of fibers, because again, I do not believe they're eating as much as needed. Starting with my own kids, with I do struggle to give them the right amount of fiber because they just hate them.
Now, I want to take it back even more from early life. So recently, I found out I'm going to be a father. And when I
Congrats.
was trying to have a baby with my wife, I really looked into fertility optimization and the role that the father's sperm and genetics can have a role to play on the eventual embryo and child, because we need to break this outdated thinking that it's all the woman's responsibility, that it's all reliant on the egg. The father contributes 50% of the DNA and genetic material, so it only stands to reason that the father's sperm can have a huge role to play in miscarriage, disease, preeclampsia, gestational diabetes, a bunch of stuff going on. So, it's a joint journey, not one person's sole responsibility. So it also stands to reason that the father's not just genetics, but epigenetics, lifestyle factors, and microbiome could have a role to play in the quality of the sperm, but also how that dictates the child's health outcomes. So, can a father's dysbiotic gut or beneficial gut impact their baby in some way?
Yes, there was, I think, probably two studies. One of them, I think, was published in Nature maybe 6 months ago, I do believe, were showing the offspring, basically the babies. They're not only influenced by the mother's microbiome, which is mostly vaginal and skin, obviously after birth and what so, but also from the father's microbiome. Again, we as a couple exchange between 23 to 36% of microbes in a couple, right? So you, by being healthy and by having a good microbiome, you're very likely influencing your wife, which again influences the child. And that is not a theoretical. That is, again, there are many studies showing that. We call it the household microbiome. How do you exchange? So you, being a father, you are actually contributing to the microbial diversity of your wife with your own microbes, and eventually contributing to the microbial diversity of your child. Now, the link, I do not believe, if I do remember correctly, I do not believe that we have tracked strains or species from the father to the baby, because that would be amazing. If we would be able to show that your bacteria, you, Karan, is potentially going to be identified in your kids or baby's microbiome. However, we do actually find and see that the mother transmit microbes and species and strains to their baby, and we can identify that this strain is actually coming from that mother in that sense, right? Even if the mother also takes some probiotics, we've also shown that we could identify some strains taken by the mother identified in the baby. although that strains had to engraft to be able to found in the baby. But I do not recall any study that actually did the tracking from the father to the baby, although I would not be surprised to identify that you're not only giving your DNA, but you're probably giving your own microbes to your baby through the mother, obviously.
Now, we've obviously discussed the topic of personalized recommendations in the biotic world, whether it's prebiotics or probiotics or any type of biotic, and specifically how our gut microbiomes vary day by day in response to the exposome, but also other lifestyle interventions that we induce it to. And that's a lot of the work that you're doing for your own startup, SwipeBiome. So can you tell me what's different about SwipeBiome as opposed to traditional companies exploring the gut microbiome, but also exploring different interventions in the biotic space?
Yeah, so at SwipeBiome, we're actually developing a software called Biome Pulse. It essentially takes the pulse of the biome. One of the biggest challenges that I have mentioned earlier is that when you want to test someone's microbiome, you take stool sample, you send it, and it takes time before it comes back. The situation has already changed. While our software is able to predict microbiome patterns in real time. So we have a proprietary software, a proprietary algorithm that takes not only your disease state, but it takes almost every single metadata you can provide to us, that we can match them with our hundreds of millions of patterns of our database that is proprietary. And we identify, okay, if a person has this age, this sex, they have this disease, and they have this BMI, and they eat vegetarian, and that's the only information we have as a metadata, we could predict what microbial patterns they would have and essentially identify what potential intervention can be given to improve the balance of that microbiota from a disease state to a more of a balanced one, in an objective to increase their treatment response. That's what we're focusing on today. We're focusing on gut health and mental health. And our goal there is to, we have, let's say, if we just speak about gut health, today in Europe, we have 332 million individuals impacted by gut health diseases, IBS, IBD, and others, right? It costs the European Union 82 billion euros yearly. And that's mostly because 1 in 3 people do not respond to their first intervention of treatment. Basically, they are on a treatment, they do not respond, and they have to go back and go back. Our goal and our intervention and our software is in the design. We bring in biotics and supplements to support the treatment and increase the response to the treatment, not replacing the doctor. The recommendation are given only to clinicians. So the clinician review the intervention and act upon or not based on what we give as an intervention. So that's our goal. And we have been working on this for the last 2 years, having proprietary software and hopefully publishing our first paper that we have looked into using the software into defining intervention between healthy individuals and colorectal cancer. We have worked on 6,500 patients as a retrospective study. Yes, that's what we're building so far.
Amazing. I mean, I think the world needs this, where it's essentially like a real-time live gut microbiome tracker, not waiting for snapshots
Absolutely.
at certain times and, prone to long lead times so the microbiome changes. I mean, I will be one of the first users of this when it comes out. So please, set me up with an account when it's out. And I know as well, given your credentials and academic interests, this is going to be so rigorous and so evidence-based and published as you're doing data as well. So, I can't wait to, add this tracker to my life as well. So, and, I must say as well that since following you on LinkedIn, I've upgraded my understanding of the microbiome and expanded my horizons so much more. And clearly, if someone listens to this conversation, they'll get a snapshot of what I'm getting on a daily basis when I chat to you, but also when I read your LinkedIn post as well. So, Amine, thank you so much for joining me.
Thanks, my friend. Very much appreciated. Thanks for having me. And good luck for you and the Loam Science as well.
A massive thank you to Dr. Amine Zorgani for joining me on the podcast. Please chuck me a sub if you've enjoyed listening to this episode and got some actionables. If you want to learn more about Loam Science and the novel 6-in-1 prebiotic fiber, then go to loamscience.com. I'll see you sentient meat bags next week.